Okay, right. We are set to go. Okay. Good morning, everyone. We are already in week 10, and yes, we are running out of. We're going towards the end of the semesters. Okay, and your week 14 is going to happen when? Let me see. Week 14. Now it's week 10, 11, 12. 13, 14. So week 14 will finish on the 16th of January. Your study week. Okay. Wait. You don't have study week. Do you have study weeks?
I don't think so.
So straight away after week 16, you're going to go for your exam, is it? Week 14. From my calculation here, are we in week 11 or week 10? Week 10, right?
Week 10.
Yeah, week 10 now. That's what I thought. 10, 11, 12, 13, 14. That means your week 14 is going to finish on the 14th, 15th of January. So straight away, that 2 weeks you're sitting for exams before going off for Chinese New Year holiday, isn't it? Okay, look. So that means your assignment handing in date will be the latest I probably could drag for you would be around the 16 to 17. Okay, so that's about almost 1 month from now, and this is group work, so we've got to say that your workload will be around by half. So I would say that you should have ample time to do this, okay, because what you have done already, like you have done the time Gantt chart and all that, okay. So that one you could actually build it up from your old project that you have done, or you can use IDP if you want to. I give you a free hand. It doesn't have to be a huge project. So based on the project selected, your own project selected, prepare a project management plan that comprises of time, cost, and quality plan. Okay. And this is when you do this, you can actually use the same thing, the same background, and the same kind of format later on for your IDP tool when you are asked to carry out this project management plan. Okay, so in this particular project, it will involve resources planning. So it means that you need to do your work breakdown structure. Then after that, this time round, like I said, I will still stick to around 12 to 15 major activities. So if your project that you previously did the Gantt chart has 12 to 15 activities already, and then you do not want to make it even bigger, you don't have to use your IDP if you don't want to, okay? It's just that if you are good to go to use your IDP, then I wouldn't suggest you use the entire project. I'll probably just suggest you go for one type of structure, meaning that either you do the civil works or you do the structural work. But the structural work, you could actually just use one row of semi-Ds or two semi-Ds or one row of terrace houses, sort of things, so you can use your project description as your IDP, which means it saves you some work in terms of cutting it down. Like you don't have to, re-describe a lot of things. You've already done it. You're preparing for your IDP anyway, so yeah, so you could do that, but it's not compulsory. It is not, it's just a suggestion, whichever is easier for you. And the requirement, like I say, is around 12 to 15 major activities. You could actually do the entire, take out all the structure, throw it away, use your IDP site, use your water drainage, sewage and road, use your civil works completely. That's fine as well. Okay. So what you can do is you are going to work breakdown, okay, to 3 layers, 2 to 3 layers, depending on whatever is required. And then you're going to break down your resources. it's going to be your labor, machineries, and also your material, 3 categories again. And then after that, from there, do your productivity rate, okay? Productivity rate calculation. And I think CPM, I will just ignore CPM, okay? Don't bother. I mean, I think you have already enough practice on CPM. So I will cut it out later on for CPM, or I will just put it inside there because this one has already been moderated. I shouldn't be changing anything. But just be reminded that you don't have to do a critical path analysis. So what you need to do is you do your resources planning, you do your production rate, and then productivity rate, then you produce your Gantt chart. After you've done your Gantt chart, with the Gantt chart, go and do your cost plan, which I've already described the detailed estimated cost plan, which is in a lot of detail the other day on how we can, I gave you samples as well. And yeah, you can actually produce your cost plan. And then after that, today I will talk about quality, and then you can actually produce your quality plan as well, based on the same work breakdown structure, okay? So yeah, then you conclude your project with time, cost, quality, and this is the format. You know this, I'll put it at 16, okay, 16, okay. Yeah, I mean, like, let me I will stick it inside here, but I will just do straight through with this, and also this one will change to 16. Okay, so it's going to be Sunday. Okay, so group is going to be 4 to 5, no 6, please. And if you want to have 3, it's fine with me. Anything less than a 5. Okay, if you want to have 3, it's fine. If you want to have 4, it's fine. If you want to have 2, it's fine. If you want to be a loner and do 1, it's fine too. You know. Okay. If you have no friends after 4 years, yeah, you could actually, I suppose. Yeah. All right. Any questions on assignments?
Dr. Ting,
Yes.
for cost plans, we are expected to do detailed estimate, is it?
Detailed estimates, correct.
Okay, and for Gantt charts, we're expected to produce a Gantt chart which with layer 3 as predecessor or successor, is it?
With layer 3, and then you use production rate to do your duration calculation. And then after that, just draw, you want to describe a little bit on, the interdependency, that's fine as well. Or if you want to do a network to show the interdependency, is very much welcome, but you don't have to do a critical path analysis.
Okay, thank you very much.
Right. So the cost plan, you need to calculate the material, the quantity of the work, and you need to calculate because the number of laborers and all that you already planned during resources planning, correct? Not, and then after you draw your Gantt chart, you just take the Gantt chart, the duration on the Gantt chart, and you need to find the rate, the production rate, productivity rate, and the rate for money is 2 different things. Please be reminded again on this matter. Okay. And production rate is about how fast they work, how effective it is, whereby the rate that you get, the money rate is money. You know, it's about how much an item costs per unit. Okay, like if let's say concrete is $300 per cubic meter, steel is $2,000 per tons. You know, so you've got to find that rate. Okay, and then you need to tell me where you get the rate from as well. It cannot be just you simply pulling things out from the air. If it's from JKR schedule of rates, then it's from JKR schedule of rates. If it is from JKR, one of the tender that you have found, or tender documents that you have found from some tenderers that they quote the rates, you can use that as well. You can go and look for CIDD if there's any rates available, local market rate. Yeah, you use those your rates, and then from there you calculate sub-portal for every layer, sub-portal for every works. And then for every major layer, you've got to have one sub-portal, okay? And then you add all the major layer will end up with one sub-portal, meaning that the third layer add up to the second layer cost, and the second layer add up to the first layer cost. So let's say pipeline works will have one cost, okay? But you've got to show us how you do it, okay? And then you just have to add up, and then that will be the final cost of construction for your project, whether it's a civil project or it's a structural project, it's civil combined with structure, that's fine, you know. So the project itself, I think you don't have to ask me what you can do and what you can't do anymore. I prefer to sort it out right here and here. You can either, like I said, use your IDP, use half of your IDP, part of your IDP, or you can use your assignment one that you did in pair work. And if it's big enough, then you build it out from there. But through assignment one, it was more like to practice how to draw Gantt chart and do CPM. Okay. So I do not need a repeat of that in a way, you know. I know now you know how to draw, you know, and I know now you know how to calculate CPM. But now I want to know if you know how to split your resources from the resources use productivity rate. The other day, I just asked you to list down the whole resources. So now I need you to attach all the resources to the different activity. Then from there, calculate your productivity rate. I mean, like get your productivity rate and calculate your duration. So this is going to be a lot more serious, okay? It's more for a lot more detail. So you keep this assignment, and the IDP tool, you just use whatever format that you have, and then you apply your IDP tool final design into this later on, and you're very good to go already. So this is going to be like maybe about 50 to 60% of your IDP tool in a way. So all the required techniques that you need for IDP tool will be here in this particular assignment. Not clear. I find myself a bit not so having a loud voice this morning. I don't know why. So I've got a question here. Can we use our previous paperwork assignment project that we've done? Yeah. Of course you can. Yeah, so you can use that project, and then you don't have to re-describe the project anymore. So everything is there, is fine. It's not like I'm going to check, you know, your last project and this project, and you know, remember every single detail, you know. So don't worry about that. And yeah, so then you continue with resources planning. Yes, correct. Yeah, Dayang, okay. Dayang, no, okay. So this is you can, okay. But now you are only needed to do group work lah, huh? So whoever is going to be helping with the write up, you know, so you got 4 or 5 person. There's about four or five things here, you see. So yeah, I mean, like it's not like people who has done you know, like let's say a group member, there is about 4 of you, you know, somebody can actually go and organize the report already, you know, and put in some of the management theory, like what is time management, what is cost management, etc. You know, so you got a bit of marks here, 10% for that, and then preparing the WBS. So yeah, the whole group can prepare the WBS together, and then one person can start to go and format your report and do up your report nicely. Even though you're using old report, there's always a way to make it nicer and better, you know, and all that. And then write up some theory while the other two can go and the other 3 can go and do up the time plan. Okay, so you don't have to wait around for time plan to be ready. The moment you have WBS, these 2 things will proceed already. It's just that when you do your Excel sheet for your cost plan, maybe the quantity bit is not so clear yet. You have to wait until, the rate bit, you times it with whatever is already, it's not ready yet, but it's okay. You just have to assume a value of 11111 in your Excel worksheet. And then when the real value comes, you just have to change the value of the duration, and that's it. You know, you're good to go, you know. And Yeah, so don't sit around waiting for people, okay? I mean, like, you can do whatever you want. You can do whatever you can now. And then quality plan is another thing. You can actually take out all the major layers and start to describe the material, machineries, testing, standards, methods needed. That is what is expected from quality plan. In fact, the person who is helping with the who is actually doing the background and all that in the beginning should actually probably do the quality plan together, because quality plan there's a fair bit of write-up as well, okay? And to do some flow charts, yeah, I'll explain that in a little while during quality management class. There is no, I mean, no, normally I don't set a maximum. I don't really set a maximum, but some students like to ask for maximum. So just put here 150 pages. So even if you go for more than 50 pages, you end up with 100 pages, I will also mark you, I won't cut your marks. But I do have a strict minimum, meaning that, with a project like this, if you give me 10 pages, then you are basically looking to commit suicide, I suppose. Yeah. Yeah, I mean, like, if you want to do that, I can't help you, right? So there should be at least some minimum here, it cannot be less than 10. I mean, with a project like this, if there's anything less than 10, then something is very, very wrong, with your work, you see. I would say 20 pages would be quite reasonable as a minimum, actually. So you can see the quantum of the work that you do here, and that's why it is called group work, okay? It's called group. This is group, yeah? So you're not doing this alone. If it's doing this alone, I give you 1 month, then I need to be shocked, okay? Then I am having too much of a high hope on your ability, which I think you have, but let's not put too much high hope on it. Yep. Any other questions from anyone else on the assignment, on the project? Project is not assignment. This is going to cost 25% of the overall marks. And if we do it well, do it reasonably neat and tidy with all the proper background, conclusion, presentation, and the format and everything, easily this sort of project, you could actually score easily 17, 18. The good ones will probably score like 22, 23, out of 25, So if you actually get like 12 out of 12 or 13 or something like that out of 25, that can only means one thing, that I am actually not happy with your work because you've copied from somebody somewhere that I recall, or there are actually some seniors who actually copy from, like some seniors here who are repeating the course, they actually forget that this is the different assignments from last year, and then they actually give me the same thing from what they did last year. And then I was like, wow, they don't even know what assignment it is, you see, but I still passed them with 12 because they did do something, So don't, yeah, I mean, if you're getting 12, 13, that kind of marks is actually quite bad, okay? So if it's a really, really poor assignment, normally ranging from 16, 15, 16 is already considered as poor, okay? Meaning that you're not giving enough detail, you're just barely scratching the surface sort of things, And yeah, averagely, everybody should be getting around 17, 18, 19, even 20. Yeah, so anything 16 and below is not great, okay? And yeah, medical and above average would be about 20, 18 to 20. Yeah. Medium will be about 17 something. Okay? And the good ones will really be getting like 23, 22. And anything over 20 is some marks that I'll give when I'm quite impressed. Okay.
Dr. Ting,
Yes, Ellen.
I have questions on the work background structure here. You might have mentioned this in class before, so if I miss it, I'm really sorry.
Okay, go ahead.
During my assignments, I realized that me and my friends have a different understanding in the list of machineries and manpower. Okay, let's say now it's site clearing, then we need let's say a bulldozer. So in machinery, there will be a bulldozer. And then in manpower, there will be a bulldozer operator. That's what my friend thought. And my thought is, this come in a package. if I rent a bulldozer, it comes with a operator, so I don't need to break it up. Which one do you think is the correct way to think with?
Actually, both is correct. I mean, if you want to, I mean, if let's say your company, there's some construction company that owns the machine, you see, so they would actually have a manpower of a bulldozer driver on the pay list as well. Okay, so in that sense, it's actually okay to have both. Okay, it's a matter of you all list it down very clearly in your resources list, whether if you talk about machines, you're going to come with the operator, so as a package, or you have a separate, like you separate them. Both is not wrong, Alan. Yeah.
I see.
And in some cases, most constructions, most I would say, would actually engage bulldozer. I mean, they most will actually engage, rent a bulldozer that comes with a driver. Nobody really would actually rent a bulldozer without a driver because it is very special. It's just like a crane machine, power crane. You can't come without an operator. Yeah, like all these specialized machineries, normally it will come as a package. Okay. So your thought is not wrong. In fact, it is correct, and it is what majority of the people will be looking at. Okay, but your friend's thought is not wrong either, because if you want to split up people, and machine, there's nothing wrong with that. Okay, it's just that when you come to the rate, you have to be very careful. You know, the rate of calculation for the money. So you either, if you split up in your resources list, that means the one rate will go to the machine itself, one rate will go to the driver itself. But if you go for a package, normally you just reuse the rental package at 500 per day, comes with operator. So the only difference, it will not make any difference in the Gantt chart. Okay. No matter what is it has to be driven by the operator. Okay. Then it will make a big difference when it comes to money rate lah. Money rate will be more obvious lah, when it comes to whether you need to put it in one package, or if let's say you calculate $500 per day, you know, you already put $500 per day to the machine and actually comes in with the operator, but you give another $100 a day to the operator, you know, so that means you're actually a little bit like double counting already.
Understood.
Yeah. And of course, productivity rate, I think your issue, I can actually see where your issue is, because like you're feeling that, you know, like production rate, also the driver will have one production rate and machinery will have one production rate. If you split it up, you need two production rate. Am I right? Are you worried?
Correct. That's the point.
Okay. So if you're worried about two production rate, it's okay, you know, you can still split them, but use one production rate.
Oh, okay. Okay.
The overall production rate of running that machine. Yeah.
All right. Thank you very much.
So it doesn't have to, I mean, obviously it has to be, maybe the machine was in the booklet or in the whatever catalog, it says that they can do how many meter cube of soil a day, for example. But maybe you would need to factor it down a little bit, because it is run by a human being who can actually get sick or ill, or you know, who can actually have mood, you know. So you may have to factor whatever that is in the catalog down a little bit, because it is run by a human being. Okay.
Okay, understood.
You understand, Alan? Yeah.
No problem. Thank you very much.
As you present logic clearly, you should be fine. Okay, you should be very fine, actually. So just watch out. So if you want to split, you make sure that in the rate for the production rate, you need to factor down the machine production rate a little bit. It's all about you being careful or not careful. Then if you, the other one, if you do split it up, just make sure that you do the calculation. You don't double calculate these two things.
Okay.
So you need to split certain percentage go to machines. The money rate into the certain percentage go to the machine, certain percentage go to the. So yeah, I mean, like maybe after listening to this, I just put them Just put them together, it would be easier.
Oh yeah, Dr. Ting, when we're talking about this project, since we are talking about a detailed estimate, right?
Yep.
Let's say we own the machine, then technically we don't need any hiring cost, but we need maintenance cost. Do you need to see that maintenance cost?
Because when you come up with the rate for that machine, you need to actually tell me how you come up with the ownership rate, meaning that the machine, there will be ownership component, there will be a maintenance component.
I see.
Yeah. So in order to project that rate of machine, you have the rate for money rate like we're talking about here, huh?
Yes.
Then you need to actually show us how you arrive at that rate of, let's say, 450 per day, versus 600 per day if you rent.
Okay.
So where should you
Understand.
get 450? You see, it's definitely comprising of ownership, meaning that you buy that machine and then it's gonna depreciate for the next so many years. Okay. So per year, this is the cost of running. I mean, this is the cost of owning that machine. Okay. Because after 6, 7 years, you definitely have to have some form of replacement or, maintenance and all that. So you need to be able to show us that this 450 is based on ownership plus maintenance plus servicing plus then you come up with that rate. But obviously I wouldn't be so particular about like whether you get ownership, your calculation is 350 or 300 or 500 per month or per day kind of thing. So I mean, it's just your awareness on that. When you come up with the rate, you need to be able to see that there is a few things that goes into calculating that rate. So the number punching bit, I wouldn't be so particular about it. Meaning that if you say, if your group says that the ownership of this particular machine is 350 and another group member say is 375, I'm not going to mark you wrong and mark him right, or mark him right and mark you wrong, kind of thing.
Understood.
There's always some leeways, and different company also they manage it differently as well, and that rate can be a big range in a sense, yeah.
Okay.
If you're buying different machine, also there's different prices as well. So yeah, I mean, if from a guy, buying secondhand and buying brand new, and for a machine company, for let's say a contractor who are so big, they have a lot of machines, they have a lot of group, they have very close relationship with the machine suppliers. So they could probably get a lot of cheaper things and maintenance and all that. So it's okay the rate to be cheaper, you see. So from somebody who is just buying one machine every 10 years, obviously you won't get a big discount, you see. Yeah. So it's good to consider all these things. It does make a difference. I mean, obviously these small things will make a difference in the final price of the project, and meaning that you will either win the tender, lose the tender, or make more money or make less money. Yeah, that would be whether making to see that your project is profitable or not. But normally as a contractor, we would actually consider many things like this. We would sit down and consider, do we want to invest in the machine this time for this project? Maybe if it's a long-term project, it's running for 2-3 months, 2-3 years, we may consider buying a second-hand machine. But we need to think about the ownership component, the maintenance component, and whether it's going to be cheaper, a lot cheaper compared to renting it off just like that, see?
Okay, I understand. I just need to show you the thought process if I do the thing like that.
Correct.
Okay. Thank you very much.
I just don't want you to just simply put up any rate from somewhere, and then give me a whole list of rates, and the rates has no basis at all. If you get it from CIDB, if you get it from JKR, if you get it from a tender, if you get it from your own calculation, based on market pricing, or you get it from interviews with some people. Yeah, you just remark it on the side of the rates, you see. Always put that as a practice, because otherwise, there are some examiners who may have the tendency of asking, how do you know this? Like, where did you get this from? So you must be able to answer them. Any other questions? No? Really? Good. So yeah, I mean, like, as we go along, digest the things first. I'll post it up today. Break up into your groups. Talk about it first. Anything that you're unclear as you go along the way, you'll be still seeing me for the next so many weeks. So yeah, so we still can continue asking questions and all that. Anything on IDP that you want me to address? You're progressing well. Any issues on conceptual, parametric, or uprate? At the end of the day, I just want you to appreciate that for IDP1, you either use parametric estimates or you use O-up rate, but it does not mean that the two of them cannot be combined, okay? Let me show you, I actually did something with my master's group over the weekend, and I feel like maybe it's a good thing to show you here as well. Yeah, I mean, let me open up the files and I'll show you the formula. Okay. EMEM. I think I really should post up this for you as well. Okay. So the cost for the analogy normally is something like this. So 1 and 1 base index is just basically whatever are you going to be using numbers or capacities? Just one index, okay? So 1 is basically the sample. 1 is a sample sample facilities or sample project that you are referring to. 2 is your project that you are looking to calculate. So the index can be things like, the factory can produce how many meter cube of concrete per day, So it's just some units lah. I mean, and that unit is only one unit, you see. One index on one unit lah, huh? So if you're looking at houses, okay, the old project has 70 terrace houses. So that is one unit. So you will be looking at the cost. This is the cost for that particular unit. Okay. Right, this is the cost for that particular unit. You times it with this one, the whole thing over the rooted. So this is the index. This is your capacity. So theirs is 70 houses. Yours is 80 houses. So 80 over 70 to the 2/3 times by the cost. So this will be the analogy kind of calculation. For parametric, basically it's quite simple. Parametric is just like if you're picking up the structure cost, for example, you just take two parameters. You just take two parameters and then, like let's say structure cost, you take steels and concrete. So with that, you just calculate based on, this one can be based on old projects, like another old projects that you are looking at. So you can look at different projects and different, for one project that you're doing with so many different components, you can look at different projects, past historical data. So you just basically take their past historical data and split up into percentage, like how much goes to, how much their tons of steels, how much their meter cube of steels that work out to be their structural costs. You see, then after that you project that into yours. Okay, I don't know if you have any problem doing this, but these are the formulas. And or if you use waterworks now, then you can, I've mentioned it many times in terms of waterworks costs. Waterworks, you could actually have like a meter length times by money plus numbers of pillar hydrant or Swiss valve times by per unit. So it depends on how you're going to break down your parameters. You see, so you can even have number of even plus number of Swiss valve. Again, you don't, the rate itself, you can actually, two ways you can actually get from past historical data, or you can actually work out a simple calculation of rates, which I've mentioned to Zai, I think, or somebody like that the other day. Yeah, I mean, it will be a combined simple calculation of all up rate, which is a combination, a combo of manpower. That rate itself is a combo of manpower rate, machinery rate, and also material rate. Okay, not calculate manpower, not calculate machinery, not calculate material and times it with 3 rates, not like that. It's just going to be one rate that has basically factored in all these things. It's just a very big wide range, wide rate. Okay, it's a very wide range thingy, you know, it's not a very specific. So this all up rate is not so accurate one. If we look at all up rate, we're looking at about 10 to 15% plus or minus one, you know. So yeah, that is the kind of error that you may have. Okay, so it's a wide range for all up. So I hope everybody kind of understood all that, you know, and proceed with your IDP successfully this time. Okay, and not mess it up with some funny BQ calculation that you're going to give to me, you know. I mean, like if I see BQ in your, if I actually see BQ in your IDP, I think I wouldn't even mark that report. I would just throw it out of the window and give you 5-0, that's it, you know, because you just are not listening at all, you see. I hope that your ears are all stropped up now, Okay, any other questions? Okay, a little bit of housekeeping. Today we're going to do project quality management. And in quality management, this is supposed to be, actually, your classes is not on time. You all are actually quite on time. The issue is, this is actually a new course plan whereby we are not supposed to be teaching you anything on contract and legal thing, okay? That is supposed to be an elective, but I felt very uncomfortable because we haven't really offered such elective for even next sem, and I don't foresee that you should be being given a disadvantage of not knowing contract administration and also contract, legal contract, and also dispute resolution. So I will still proceed with that 4 classes towards the end. So meaning that even though we are using the new course plan, that 4 classes, which is supposed to be in an elective course anymore, I'm supposed to be ending up with procurement, finishing on procurement, and that's it, you see. So I am trying to rush a little bit so that I can cover those 4 classes, because that is a 4 very general classes that you need to know. Even for people who don't take elective, at all, you should, as an engineer, it is a very important, essential part of your work in the business. You need to know what is extension of time, variation orders, you know, you need to know what is possession of site, you need to know contractual management and contract administrations and all that. So I'm still giving you that, you see. So what I'm going to do now is, because I'm giving you that 4 classes, I need to rush this a little bit. So for safety, and if I can't finish my quality class today on PQP, Project Quality Plan, I will actually post a recording up for that. So you listen to it at your own leisure over the weekend. It doesn't clash with any of the classes. So today, I'm just going to do quality management, and on Thursday, I'm going to pick up and quickly start on risk management. So supposed to be, I will still have another class on quality management plus safety management. So usually quality management would take about 1.5 classes, and safety management is about half of the class. So that 1 class, I will put it into a recording. So you watch out for that recording. I should be able to prepare it by end of the week or beginning of next week. So no worries. That will be part of the assignment. I mean, part of the project, really, you know. And this Thursday, I will move on to risk management. So I will use recording to cover up the quality management and safety management. So yeah, so please be clear on that. On Thursday, I will also repeat it again to tell you when is the recording coming out, but that recording is a follow-up from today's class, okay? So that means this week we are essentially having 3 classes. But like I said, that recording, you can listen to it over the weekend, that's fine, you know, it's no rush. Then this Thursday, I will do risk management. Then next week, I will move on to procurement management already. So procurement management, construction site management, contract administration, legal contract, and also dispute resolution. That will be the final 8 classes that you'll get from next week onwards, plus a exam wrap-up class. Okay, so this is how we're going to run it for the next few weeks. Okay? No more heavy calculation, a lot of listening and a lot of reading and all that coming up. Okay? So today's class is going to be on quality management, and we are going to talk about time, cost, quality. You see, we spend so much time, more than half a semester, 2/3 of the semester, talking about time and cost management. I mean, you can see how important it is. And sadly to say that, you know, even though quality is equally important, I'm only covering it in 1.5 to 2 classes with you. So that is the actual real life situation of how we are treating quality in a way, you see. So in construction, quality likes to be managed in a way like inspection. So many people treat quality in the old days until now, when there's construction, it's people like, it's like engineers going to site. You know, you think that your job is to check and to record, check, and demand people to rework, or if there's defects, you know, you start to get angry with people for not doing a good job by writing letters and complaints and holding people's payments. You know, that is how the construction industry has been practicing quality. It is like what we call a lab coat, meaning that, you know, when you go to lab, you wear a white coat, you know, and then your engineer's job becomes like a cat that goes after the mouse. You know, all these mice that runs around the site, you want to catch them. So your style is you just want to make sure that you are surprised. I'm here. I want to do checking today, you know. And then you take up your pen and paper, and then you go and test, and then you go and look at the things, you know, and then you go and cross, you know, cross the wall because it's a hole, cross the wall because the painting is not done, it's not even, you know, cross the window, you take a pen and spray on the window and say that this is wrong, you know. So that has been a very adversarial kind of practice. You are creating very adversarial kind of relationship on site. You're just not going to make yourself very popular. It's not like you really want to make yourself popular all the time when you're doing a job. You know, some jobs are not meant to be popular. That is fine. It's a matter of we need a good environment. We need a teamwork. We need good synergy on site for project to finish. You know, there is no good synergy when all the mice on the site are running away from the cat, and every time you appear on site, they disappear. You see, so nothing will get done if you appear on site. So why do we want to do that? You know, it is a very very bad kind of mood, you know, in that sense. You know, very in very simple language, that is how it feels like. It is very much on quality control, like we do in construction. It's very much on quality control. We just want to do controlling. We just want to go and monitor, control. Yes, monitoring and controlling is part of project quality management. But the idea of quality management actually focus on quality management as a process. So it's a system. It's a whole system that you need to call it quality management system, QMS. Okay. And there are many ways of creating a QMS. Product quality management is a kind of theory that you can apply to QMS. I mean, to make it a QMS for your project. Okay, and Six Sigma, Lean Constructions, Kaizen. You know, there are many types of new age thinking and theory that can be adopted into your project quality plan or quality management system, and that will be your system. And ISO is also one form of system. It's also a QMS. It's also a quality management system. ISO talked about a lot on documentation, the documentation, but do we really need to spend like hundreds of thousands of dollars to actually purchase an ISO system and then have audits being done to you every 2-3 years, you know, and spending another 20, 30, 50K every few years in order to get the system? Actually, ISO is just a theory. A theory is actually a theory that's been packaged into a product, and that product has been sold to you. It's just like okay, I can give you an example. If you know how to bake a cake, okay, you will know that you need 4 eggs, 200 grams of sugar, 200 grams of flour, 150 grams of butter, you know, and then, you know, some essence, and then you bake it at what temperature, and that's it, you know. So if that cake is a QMS, so you already know how to do it, right? Do you need to go to the supermarket and buy a ready mix pack? Okay, that they all tell you that just mix water into it and then put it in a tray, and or mix egg into it, or they even have egg powder inside there, you know, so you put it in the oven. So ISO is like that ready mix cake, okay? Or you don't know how to bake a cake. Okay, so maybe I talk about Malaysian curry, you know, I mean, sorry lah, we are all Malaysians, so we always talk about food. So, you know, like in the supermarket, there's a lot of like curry, laksa, packet, apa lagi, Penang prawn mee packet, you know, Assam laksa packet, you know, everything got packet one, everything is inside there, you see. So ISO is like that. ISO is just those packets. Some people who knows how to break down the formula, and then they process it and they make it into a packet, and they will sell you for like $20 per packet. So you go back, you only have to put your chicken in, you put your packet in, then after 20 minutes, your chicken is cooked, your curry is cooked, okay? So that is ISO. Whereas if you as a project manager knows the theory, knows the idea of QMS and what sort of theory you want to apply to your QMS and coming up with your own systems, you are essentially going to be the person who is going to mix the rempah together. You're going to tumbok the rempah, you're going to take the onion, you're going to take the garlic, you're going to take the lemongrass, you're going to take the curry leaves and all the, you know, cinnamon stick and all that together, then it's going to cost you $10, you see, and then the effect of it is going to be so nice. It's much nicer than those ready-mix pack, you see. So that is the example that I can differentiate between the two, the idea of ISO and the commercialized quality management system. ISO is actually a Switzerland product. It's actually a Switzerland grown kind of thing on and then the US, the Americans are always so smart, you know, they take it and they package it and they sell it to all over the world, and everybody just buy ISO, you know. I'm like, what's the point, you know? I mean, like, does it mean that if our university is an ISO university? It only means that the management of the processes of maybe the HR or the bursary or the students acceptance systems is you know, properly carry out. There's a proper systems. And it's not to say that because we are ISO certified means that you come up and you can tell your employer that I'm an ISO certified student, you know. So like, you can't sell that honestly. No one will actually buy you up, you know, because no one will actually kind of like think that is a plus point because your university is the ISO university, you see. So yeah, I mean, that is the point of ISO. Don't just apply ISO to every single thing under the sun, you see. I mean, that is a bit ridiculous. So the idea what I'm talking about here is basically quality management is a system, is a process. It's a process that has that is put into a system, and it should be very much tailor-made to your own organization, the nature of your own organization business. If your business is construction, if your business is consultancy, you know, you should have a system to make sure that the product that you design, the work that you do will end up to be good quality. Okay, and that is system. So there is many theory. There are theories behind creating these systems. So what I would like to give my students is those theories that build up those systems, so that all of you are able to actually come up with the systems once you have gone through one or two projects. You started to get mature. You started to have 5 years in the industry. You have gotten some maturity on, you know, the work that you've done. You could actually create your own systems, and it's not hard. It's all about Excel worksheet. It's all about, you know, rubrics and theories, you know. I mean, rubrics and also maybe some formulas, you know, that you can actually input. And, you know, it's about methods and processes. It's about, you know, having a proper sequencing, work method statements and all that. So that is all part and parcel of having a QMS, the quality management systems for civil engineering. And a lot of us, I hope that you don't walk out of here, and some of you will get engaged by maybe a quality management company. You know, nowadays there's a lot of consultancy that focus on quality management, and then they will actually employ quality manager for their job. Okay, and yeah, I mean, it's fine to do a job like that. You know, it is actually very fine. It's just a matter of you do not understand, you know, what is behind, what is really quality management systems. So a lot of civil engineering treat it like a last minute inspection, treat it like a last minute controlling, and treat it like specification. So all you care about is the specs. You take the specs, you go to site, you read the specs, and then you start to pack based on the specs. So a lot of civil engineers are actually pretty much constrained to that kind of thoughts, you know, and that kind of processes. And you see that a lot in now in some of the sites that I have been to and all that. They still have that kind of attitude. So they want to do checking, they want to pick up the specs, and they want to write letters and complain to the contractor, to the client, that, you know, these are not following the specs. The spec says that plus or minus 2 mm, you know, the calculation after the thing after the concrete has been poured is actually 1.5 mm, for example. You know, and then they requested for demolishing and reworking and all that. And there's a lot of dispute and a lot of anger and a lot of like shouting and a lot of meetings, you know, going through solving problems because the engineers are not doing the right thing. You know, they're not treating quality management like a process. They are treating quality management like specs plus last minute inspection. So they treat themselves like a white coat inspector instead. Okay. So before we go into that, so my emphasis is quality is not the final product. It is not the process. It is about processes. It's not about product. It's not about going in and look at the wall. It's not about going in and look at the pipe. You know, it's not about taking a water bottle and you look at it and say, okay, I describe the water bottle now, that the cap is this big, and it is screwed how many times, it can fill up 750 ml of water, you know, like that is product, okay? That is product. You're checking the product. And when you're checking the product and throwing away the product, you are actually increasing the cost of quality already. Meaning that you reject this, you need to redo it. Who's going to pay for it, you see? So when we talk about product, okay, when we talk about product, you know, it's not a process. You need to look into the whole process of coming up with this particular product that will look after every single processes from the input of material to the input of workmanship. So it's not about, I'll give you another example. It's not about you taking a piece of shirt or a beautiful dress, okay, that you send some guy to the tailor, and then you come back and then you check, oh, okay, this the workmanship is nice or not, you know, the size is okay or not, etc., etc. So if you're looking at that dress as a product, then you forgot that in order to have a good product at this end, you must have good material, meaning that the dyeing, the benang, you know, must be of certain standards. You know, if it's silk, if it's chiffon, if it's French lace, you know, there is different quality. Okay, so the product that you input, your concrete, your steel bars, you know, there must be some form of standards and some form of quality to it. Material is a very big part of the quality management. And then you need to look at that tailor, you know, the person working on it, the workmanship, the manpower, the people, they have the skills or not in doing things like this, okay? You can give them, you can buy French lace that is costing like 1,000 per meter, you know, and you send to somebody who knows nuts about this and start to cut it left, right, and center, you know, before you know it, the whole $2,000 piece of 2 meters clothes is bye-bye already. So same thing, you know, you can have good material up to the site and the manpower doesn't know what to do about it. And then you need a good machine. Some machine has, you know, some clothes have to be dealt with some very specialty machines. It's just not any machine, sewing machine can do, you see. And some of it needs to be hand sewn. Some of it needs to be, like the beads needs to be specially tied in, you know, and all that. Otherwise, how to make a $20,000 dress, you know, worn by princesses and all that? Okay, so why, you know, there is a difference. The machines, the hand, the people, the workmanship, and then finally the methods of doing it. You know, there are methods, there are ways of doing it so that you will end up having that final product. So again, same analogy that you apply to construction, and even more complicated and even more under a very open, difficult to control kind of environment. Okay. So yeah, that is what we meant by quality is a process, not a product. Okay. So now we must recognize the QM is actually input to the process, not an attribute of the output. This is a very important sentence that you must always remember about quality. Okay. It's not about attribute. It's not about the features, the final features. If we civil engineers are concentrating on the final features, then everything is too late. By the time you get up to the stage of checking everything before you hand over to your client or hand over to your house buyer, it's already too late. If something is wrong, that's it. You know, you need to rework everything. You can't rework everything, and people just have to accept that lousier quality or lower quality product. Okay, so there are definition of quality management. So, but before we talk about what is quality. So quality is about features, about characteristic. It's about the overall features that is able to satisfy the stated and implied needs. Okay, so this sentence here reminds you that yes, even though it's about the features, the characteristic of the product, but at the end of the day, you must know what is the stated and implied needs. So what is the stated needs? What is the implied needs? You get what I mean? Okay, so you need to know what the client wants. Yeah, you need to know what the client wants. So quality is about conformance to requirements, standards, fulfilling what was originally proposed. You see, so there is many layers here. Many layers. It's not just about, you don't read a sentence and say that, okay, it's about features, about characters. It's not like that. Okay, you don't read and say, okay, it's about standards and requirements. It's not like that. You have to read the overall sentence together, meaning that there's many layers to what is quality. But for me, quality must be at least fit for its intended purpose. This is very minimum. It's just that I say today that I want to go out and buy myself a handphone. So minimum is my requirement of the handphone, that the one that I buy, I must be able to pick up calls and call people, and put up message, at least an SMS. So if that is a handphone requirement, that is the intended purpose, intended use of my handphone, then that is quality, that is minimal. I've already met that quality. So if I go and get a $50 handphone, that is, Nokia from 10 years back, that is also a handphone. You cannot say that it's not good quality because the intended use is only that. But nowadays, everybody go for smartphone. So those become low quality and smartphone becomes quality, you see. So you need to know what is the intended purpose. If it's I build a house, the minimum intended purpose is it must be able to let people live in there without any major issues, like your roof is leaking, your window is leaking or whatever. Those are like, if it's uninhabitable, then that is not its intended purpose. The house must be habitable. People must live inside there. Okay, and whether it's super comfortable, whether it looks good, whether it use high class, low class material, that is another story. So intended purpose is just that, habitable, not habitable. The water pipeline must carry water, must produce 10 bars of water at the end of the line. That is intended use. Okay, the drain must be able to carry discharge for a 1 in 50 years rain, for example. Okay, so that is the intended purpose. So it is actually a very relative thing. Okay, so I would say that, ladies and gentlemen, when we talk about quality, it has to be, you cannot think of it as like a dual. You cannot think of it as absolute. I shouldn't use the word absolute, because when you already set it as it is, it should be already absolute. But when you are setting the quality requirement, it is very much dependent on the other end, which is the people who accept it at the end. So it's about meeting of the minds of the people or the group of clients or the group of intended user. So you must understand that it is a very relative. It's absolute in a sense, but it's relative to the intended users. So that is something that you must be aware of, especially for us in civil engineering, in construction. So there are many descriptions. One of them is a relative quality, which is, you see the word relative, this is absolute, but and related to a comparison of features and characteristics of products. Okay, it is not a very good definition, but obviously, some people do that because they compare one thing with another thing, you see. So if like you can't do that if you're going to compare, if you're going to buy a car and you only have 70,000 budget, how can you compare a Proton with like a 70,000, you want to buy an SUV, you want to buy an X70? How can you compare that X70 with, let's say, a Toyota, Innova or something, or Honda or whatever? So you see, it's like it has to be relative, but you cannot be the features is there's a tendency to be there's a tendency to compare, okay, but it must be relative to the end user, okay. That is what I'm trying to say. And then if it's product based, some industry is very much product based, so you must have some product features that are there, like for example, like I said, handphone, your handphone must have a lifelong battery. And what do you mean by lifelong battery, you see? And then user base, meaning that it's intended purpose. And then manufacturing, like to say conformance to certain specification. And manufacturing are usually product and manufacturing based kind of is that kind of definition, okay. But no matter what, okay, there's another one that's value based, which is relating performance, like how well it is performing and all that. So there's many different type of definition. Then for us in civil engineering, I would tend to go for this particular definition. That means quality actually is multi-level. It's many layers. I like this definition the best because I feel like it is multi-dimensional. It is multi-layer, so we should actually know which layers that you want to go for. So if you have a level 1, then it is a basic intended use with no defects and no complaint. Meaning, like I said, if you say the house is habitable, there shouldn't be any major defect that makes it inhabitable. There shouldn't be any complaints that says that I cannot live in this house, okay? And then if level 2 is conformance to certain standards and specification that is satisfied, that is detected by the statutory body. So if you build a house, you need to send it for occupational permit approval. And occupational permit approval is given by statutory body like the councils, like JKR, like the ID, all these agencies need to give approval for you to do your work. But obviously the final one usually would be the councils, okay? And then the other thing is about how long you can use it. So let's say if you buy, a lot of people say, oh, I like IKEA. IKEA has intended use. A chair is a chair, a bed is a bed, a shelf is a shelf. There's nothing wrong with that, okay? There's no defects, there's no complaint on that. It is conforming to certain standards in furniture that is being built, meaning that you don't sit on it. If it's like all the chairs must be able to hold up to 150 kilograms of weight, then they are all conforming to that standards, Then, but IKEA, is it long durability? I don't think IKEA is considered as long durability kind of item. So if your setting, your relativity is up to number 2, then IKEA is good quality. If your relativity is up to number 3, it may not be really that kind of quality. The word quality, high quality may not be in use anymore. Okay. If it's talking about good performance, efficiency, and operability, then definitely IKEA will not be that. You see, so high reliability, I do not think so. You see, so these are considered as higher levels. So you can, a car can go for this. You can drive. Yes, this is any $10,000 car that you can buy from anybody is okay. If you can drive, that is good quality if you are level 1. And then if it's, conforming to certain standards and the designer wants it to be like that, then that is certain layer. Long durability, if you can drive this car for like 10 years without any major breakdown, that's not bad. It's long durability, you see. And then high performance, obviously, if you're going to drive a Ganchel and try to speed with a BMW, then obviously, level 4 is not going to be it, you see. So, once you push your brake, once you push your accelerator, that car probably doesn't move, you see. So performance, efficiency, and operability, it has to be part of your relativity, you see. So if this is not part of the relativity, don't go and check and say that this is no good, you see. High reliability means that consistently you're going to be using it, it doesn't break down, that's good, you know. I mean, you don't want a car to be stuck in the middle of the road, you know, in the middle of a traffic light, you know, and you know, that everybody drive past and look at you, and then you're like, oh dear, you know, I wish there's a hole that can swallow me up, see. So yes, you level 5. Level 6 is serviceability, meaning that you can use it in various environments. You can use the car in the snow, you can use the car under the hot sun, you can use the car to swim if you want to, you know. So I mean, if it's design supposed to be like that, level 6, then it is level 6. Then you have to check against level 6. 7 and 8 is something that you must be very careful with, because a lot of us, if we do last minute inspection and the last minute kind of thing, we would actually have a tendency to go for this aesthetic, you know, how good it is. And this one here is very simple. Beauty is in the eye of the beholder. Okay. And some people even further go for perceived quality. It's just like you all, you know, when you first day you walk into uni, you know, you've got hundreds of classmates, you know. Some of you are probably roaming around looking at, hey, is there any good looking chap, you know, nice looking guy somewhere? And some of you are probably looking up and see if there's any pretty looking girls, you know, in my class, so that it gives me more motivation to wake up every morning and attend the class, because there is some eye candy to look at, you see. So that is aesthetic. But if you ask your friend, you know, if you think that guy is good looking, or you think that girl is good looking, you know, like if you ask 10 person about the girl you think is good looking, then maybe there will be 1 or 2. If she's not a standard looking beauty, then maybe there will be at least another 4 or 5 person who said that, okay, sajak lah, pa you buka ka, you know. So attractive to the eyes is a very dangerous thing, you know. Aesthetic values is very dangerous when we come to using it on, you know, very engineering kind of work, you see. So if we want to base it on attractiveness, then a lot of things will probably not pass, you see. Perceived quality, again, is about feel, you see. I mean, like, when, you know, some of you after 4 years in uni, you actually end up with a girlfriend or a boyfriend. Obviously, that person out of the 100 over of them, you know, is the person that actually gives you a better feel, you know, and you know, more ngam kind of thing, you see. So again, this perceived quality is even worse. So it's just like, if I want to buy a house, I walk into the house and I want to feel whether I feel good about it. There are house buyers who do that, you know, and that is their level of standard, but they don't look at anything else but the perceived qualities, and that will be a bit hard. You know, these sort of people will be a bit hard to really satisfy in that sense. You know, not everything will satisfy them. Not every house you build will satisfy them. So because it is perceived quality, then, you know, if you perceive that this house has hantu in it, then you know, when you walk in a house, you say that, oh, my goosebump creeps out, you know, so I cannot buy this house. So does that mean that the house actually have no good quality? Maybe it is built according to the specification the council's already give you permit. You know, everything inside there is of reasonable, good performance. It's not bad, you know, it's actually level 4 or 5. But then there's somebody who comes in and have a level 8, that means you fail everything, you see. So this relativity, for us engineers, we normally would potentially go up to like level 6 or level 5 or even level 4, you know. We would actually specify that sort of standards. But again, whether you want to specify that sort of standards, quality has a cost attached to it, you see. When there's a cost attached to it, meaning that you can call for very, very high standards, but it will be expensive. There will be a difference in terms of dollars and cents. Okay. And if you go for low quality, I mean like lower quality, there will also be maintenance costs and also replacement costs later attached to it. So it's always about what? It's always about the end user. Remember that. So that relativity, even if we define the quality to this level, based on this level, or you want to go for the user base or the product base or transcendent. Transcendent is the perceived quality, you cannot define it, you just know it, like sometimes, you ask, you ask your friend, why you marry this guy, and they say, I don't know, it just feels right, that is transcendent. Come on, we're not going to go that, we're not going to apply that into the final, features of our product in that sense, that would be impossible to even satisfy in that sense, to go for the perceived feelings. Yeah. So really what you should do is to make it very logical, to make it, the definition of your quality should be very logical. It should be very, not to say general, but it should be logical, rational, and at the end of the day, it must be relative to what? To this concept here, the big concept here of customer's requirement. Okay, so you must meet the mind of the client. As a designer, you must talk to the client and see what they want. What is their budget? What is their thinking? Who is the paymasters? These are some of the questions that you have to remember. So, the husband may be the paymaster, but the wife is the one using it. So please ask the wife how she wants the kitchen to be designed, you see. So if you ask the man look at your design and say, okay, that's fine, go for it. And then when the wife comes in and says, I can't use this, I can't turn in my kitchen, I can't cook here, then for her, your job, your design is lousy because she cannot use it. Even though the paymaster is saying that, oh, okay, yeah, I mean, I say yes to the design, but then you're not going to have a happy customer. So again, customer's requirement also, you have to know who is the customer, who is the end user. The end user and the paymasters may be two different persons. Both you have to take care of, okay? And so it is the best to conform to customers' requirement, and then it must be operating based on what the customer wants. It's just a handphone, car, house, everything is based on whoever that is going to be using it, what is their requirement. So you must sell something right. A lot of times, quality is not good. It's because you're not selling the right thing. You're not designing the right thing. You're not giving the customer what they need and what they want. You are putting out what you think is the best. You see, so the definition of quality, when you start a project, when you start your design, when you start your construction, when you start your procurement, you must understand. You must understand first how do you define this particular project? Okay, how do you define the end product? What does your customer want? Who is your customer? Who is your paymasters? Who is your end user? Okay. So if you're going to design something that a Ferrari can run onto it, and you forgot that this road is just going to be normal end user. Yes, you're going to design that. That is very high standard. You're going to build it to high standard. That means a Ferrari or Porsche special kind of road. Then yes, that's fine. But you have to realize that money. Is your client going to pay for that? You see. So you must understand who is your end users, who is your paymasters. So once you got that sorted out, then you will define what level of quality that you want, what sort of definition that you want, and then you start to design accordingly and then try to match the mind of the client. So before the construction work actually start, all these things must be settled first. You must spend time on it. A lot of designers, they do not like to spend time. The consultant, they do not spend time in understanding what is the need. JKR may call for the project, but the client, the end user could be the people of that region or that country. Majlis Padawan Council may call for a project to build a recreation park, but then Majlis Padawan Council are not the one that goes to the park every day, you see. So the people that goes to the park every day is the runner, is the people going exercise, is the family, is the children that using it. So again, we need to understand the needs, okay, of this group of people. So once you get that out, you have to remember why you want to manage quality. Because project management, Dr. Ting says source, time, cost, quality, all very important, It's not like that. Because it affects money. Quality, there's a cost of quality in the construction industry. If you produce a work that is problematic, you need to do a lot of reworking. Or, for example, the beam is too thin, the slab is too thin, the cover is too thin, then you have cracks on the wall, you have cracks on the beam, you have cracks on the column. So it's going to make things very undesirable. You're not meeting the requirement. A lot of things, in that sense, there may be reworking, meaning you need to cut it off. There may be honeycomb that you cannot use. It's going to reduce the strength of the whole structure, for example. Then you may need to do concrete strengthening, and that is extra money. So quality is very highly associated with money. You want good thing, you must pay for it, okay? But you want a certain standard, but you don't meet the standard, you have to pay for it in terms of defects, in terms of reworks, in terms of extra strengthening, in terms of taking it off, demolishing it. These are all money involved, and that is very critical. We do not, and then of course the simple things, cause of failures. You imagine a structure fails, you see, the whole beam got bended, a whole slab was deflected, it looks scary, or the whole house is tilted. Last year I actually had a project that, I was asked to study the integrity of the house. The whole house was tilted. It was literally tilted, okay? I mean, it was, we need to find out what's the reason. Is it the piling? Is it the ground condition? What was it that was not done? But it was the first time in my life I actually see a house that is actually tilted, I'm talking about proper engineering design house. I'm not talking about the kampong house that, your uncle or your brother or whatever, your father or your dato built 10 years, 20 years ago. Yeah, I mean, like that one, no engineering lah, kan, so tilted, I'm not surprised. But this is a proper engineering house, with design and all that, with councils and all that, OP and all that. And then the house is tilted, like, it's like, 15, 20 degree. I mean, like, come on, do we really want a leaning tower of pizza in Sarawak, So we do not want that, okay? So yeah, it's not going to make a Guinness World Book record in a good way, okay? So yeah, so this is things that we're looking at. There is problems when it comes to cost and also time. When you need time for extension of time to do reworking, reinstating, re-strengthening, all this we do not want this the more that we have, the more time that we need and the more increased cost that we have. So there is problems, quality may not be something that you look at immediately. Cost and time, yes, we look at it immediately, boom, we see it. There is a features here, you see. But what about quality? Quality is the last thing that you are aware of. Quality is the last thing that you are aware of. Okay, but then it is one thing that will come out. The effect will come out later. So that's why many of us are not really caring about it in that sense. Okay, so that is the background of why you should remember when you manage your site, you must manage quality, you must manage time. Yes, time, when you see the schedule delay, straight away delay, everybody hoo-ha. Budget overrun, yes, straight away, S-curve tells you budget overrun, you get a hoo-ha out of it. So quality is something very subtle. It creeps onto you, it comes in slowly, and before you know it, it's a big thing. Okay, so it's something that you need to manage. Any questions on this? No? No questions? No questions, I will move on to the next section. So quality management, there is a history of quality management that it has actually gone through 5 eras, really. You know, the first era was actually quality inspection. This is like after, this is during the time where the way earlier one was during industrialization, 1910s, you know, 1920s, in the era where after World War One. So people start to work in groups like factory environment. So they realized that the product that was being built was actually dropping in standards. And then after that, they moved into after World War II. There was a lot of issues on quality, the product that was produced, because everything, a lot of rebuilding was done, a lot of construction material was needed, a lot of facilities are needed after World War II. So then, but many things was actually built, but not according to a certain standard. Then there is the era of QC, and this is whereby the American and the Japanese are moving in with people like Deming, Durand, and Crosby. So there is a few gurus that are, you know, very, very popular, very, very famous. These people like Deming, Durand, and Crosby, they have created. There are some of the fathers of quality management, and it started off from the era of QC, QA, and then slowly, I think there are a few like Ishikawa and all that. They moved into the era of total quality control, and also quality control tools, statistical processes, and all that. You can read all this online actually. And it's just going to introduce to you, there are many, these are some of the projection, and a lot of these theories are actually still being used in our today's quality management era. So Durand talks about quality control improvement. So it means that even if you want to control quality, okay, if it's within certain region, then the cost will probably be fixed at certain region. But if you want to control too much into a lower percentage, also you may have problems that the cost of controlling may get too high. So the features is always like, you need to know where is your current level, what kind of defects that you're always getting, and then try to reduce down to the lower level, but without increasing too much of the cost of controlling. So that was what Durand was talking about, okay? And they have a Durand trilogy, which we talk about in something like this, you know, the lesson learned, you know, and then moving into the new region of quality control. And then Ishikawa is very statistical control processes. He is the one that created a fishbone diagram to find out why certain things happen. You know, it's a very specific ways of certain things, finding out the root causes of certain things. And then he also talks about the 7 control charts. So this is not a 7 deadly sins, and these are 7 quality control tool: Pareto, scatter, histogram, control chart, run chart, flow chart. So out of these many things, I love flow chart. So you will see that I would ask you to do flow chart, okay, for your PQP later. Okay. So this is philosophy. So I mean, this video is just to introduce how quality actually evolved from one era to the other era. It changes, but unfortunately, construction has more or less stuck in this era. Okay, and the latest, no, I would say latest era, but the more applicable era is the more recent one, which we talk about TQM. And in fact, they are applying what all these TQM are applying all these things from different Crosby, Durand, Deming into quality management. Besides talking about statistical processes, besides talking about checking and going to site and look at the features, you know, and besides collecting data and finding out what are the root causes of the problem, we actually want total quality management, meaning culture. So then we're looking into leadership, and the leadership of the company who will actually support quality management, the middle management who will actually execute the work disciplinely, and the lower, the site people, featuring the site people and the factory production line, people understanding the importance of quality and follow through with that. And I think for construction, we are more or less stuck with the middle management and also the lower end, the site. So what is the reason? And people must be motivated, they must be trained, and they must understand why it's important to do the job well. It's just that I like to give let's say a cleaning company. A cleaning company may have the water quality management. And what do we mean by that? It means that the management will support the work that is being done by the whole company. So if the company is going to clean the universities or clean a hotel or clean offices, so their workers must be able to understand why they must mix the liquid detergent with water, with warm water, with whatever soap or bicarbonate soda or whatever you call it. They must understand all the methods. They must understand, because they are the ones executing it. They must understand how to use that broom, how to use that vacuum cleaner, how to use it properly. So if they understand it and they are motivated to do it, then you will need to know that the middle management, the people, the supervisors, the manager who goes and check and all that, must be able to uphold. They must be able to discipline this thing, this management method, you see. And then they must be supported by top management. So then you have a total management, TQM, total quality management. Okay? So with this, we can actually smoothly move on to using TQM as part of your QMS. Okay, and to have a QMS is a system. Usually it goes for the hard way. QMS is like a hard way. We talk about QP, quality planning, quality assurance, quality control. And what are the methods, what are the material, what are the manpower? All these things are part of QMS. But you must understand that QMS, if you feature it with TQM, you must get people support. You must get management support. You must get investment of equipment, materials, better quality in order to do the job well. So applying TQM in your QMS, it means that you are also, it is a total well-rounded sort of management styles. Okay, and to do that for your site, okay, it takes a lot of parties to be involved, and it takes a lot of discipline. So your job as an engineer, a lot of you will end up in that middle management layer first. So it's about you having discipline enough to carry out the processes that is required and to motivate the lower ground staff in order to carry out the job according to certain methods, materials, and workmanship requirement, testings requirement, and all that. So you are only one part of the features, but you must have overall features. You must get that motivation to do that as well. It's not about, oh, it's my job. I get paid $2,000. I get $5,000 payment as a quality manager. This is my job. I just do my job. It's about you really wanting to do a good work for the end user. So you see, it's a big range. And then on the other end of the range is the end user. On the other range of the range is the customer. So you've got customer satisfaction, you've got customers' requirement, and you've got management, you've got middle management, you've got ground people, you've got end users. So this is a big whole range of everybody working together for quality management to truly works well. Otherwise, we are still going to be stuck. We're going to still be stuck in that go to site and check kind of image. Okay, so here we'll talk about quality TQM. What is quality? Total quality management. So it's not about whether the product is not good or good or whatever. It's about an approach. TQM is approach. It's a management approach that is people orientated, measurement driven, customer focused, long term, and then you keep on wanting to do better. It's about a culture. It's about think quality, talk quality, plan quality, do quality. So if we talk about a hotel, a 5-star hotel, that people are realized that even the housekeeper knows that her job is so important for the hotel to maintain 5 stars. That is TQM. The bellboy also knows that it's important to open doors, close doors, pick up bags, greet people well enough so that your hotel is 5 stars. So that is total. No, if no use that the top quality management says, we want our hotel to be 5 stars. The middle management says, yes, we have processes, we have designed these processes, but the ground people don't do it. When the housekeeper sweep the floor, they never vacuum it. When they clean up the bed, when they fold the sheets, they never do it properly. When they clean up the laundry, they never clean up properly. They still stands on the sheet. How can you be living in a 5-star hotel when all these are not right? You see, so again, TQM is the culture. It's everybody realizing that it is important to strive for it. Okay, and honestly speaking, our ground people are not up to that part. And now recently, I've been trying to do some research on that area. Like how people, like ground people, how can we actually make our industry a better industry in terms of workmanship? Because the problem do come from this group of people. Okay, I'm not saying that the other group and other things and other mentality is not right. It's all correct, perfect. But middle management, like you as young engineers, if you go down to the site and behave like a cat, taking your pen and start to scratch here and there, and then start to behave like a lab coat policeman, then we will definitely still have problems as well, you see. So don't, you see. So again, TQM strive for that delivery and the outcome. It is both. And this is the reason why we want to apply TQM. So you give it a read through, okay? And now there's this also about why TQM and traditional quality management, what is the difference, you see? So traditional one is that you fix the problem. You're doing emergency management. You got a call, the thing is not right, you find ways to rectify it, okay? Then, whereas total quality management look at the whole processes. It talks about different inputs. It talks about material processes. It talks about manpower processes. It talks about workmanship. It talks about testing requirement. It talks about who look after what. You see, so if the whole processes is being lined up properly and the people impact is there, or all properly done and featured and all that, then we would generally not have too much of a problem. Okay, all right. So it's not quick fix. It's actually a process management. It's about controlling people. Total quality management, empowering people. It's about customer satisfaction. So this one, traditional management, is the bottom line, the profit, the figures. If you make money, then that's good. If you don't make money, that's not good. You see, so it's TQM realized that there's behind quality, there's a lot of money involved. Okay, so this is the features of TQM. So now there are actually some concept that goes beyond TQM. Okay, so like Six Sigma, Lean, yeah, a lot of these other features coming in, also trying to improve on TQM. So in the near future, you will go beyond TQM. At the moment, we are applying TQM. ISO is about TQM as well, So yes, so now the active features of QP, QA, QC. I think the time is actually basically up already. I don't want to go into this. I think I'll probably put this all in recording later on, okay? And I will go through with you. So TQM in us if we want to create a QMS, a quality management system that is based on TQM, the concept and theory of TQM, you must have QP. And in QP, you must create what we call a quality manual. And quality manual in engineering is what we have called a PQP, a project quality plan. And in the project quality plan, you also plan the processes of doing things, methods of doing things, the material required, and the machineries, any specialties machinery needed, any work method that is required. So under that umbrella of under the umbrella of QP, you need to create what we call a quality plan. And we no longer call it specification, okay? If you say that your quality plan is specifications, then you guys are still in that whole era and you haven't been listening to this lecture at all. So my concept of quality manual, in factory, there are manuals, okay? In construction, we have project quality plan. And in the project quality plan, we have many elements. We have procedures, we have we have the people, we have the resources, we have the cost analysis. We also have this part is what is needed, you know, for your PQP. Like you need to understand all these things for you to create your PQP. And your PQP will include drawings, include methods, include tests, include what sort of tests you need to do and how you do it. And wrong spelling. Okay. It will also include change, variation, order processes. It will include material features that is required. It will also include the flow of things as well. So I like to create it with flow, meaning that if I use PQP, if I create my PQP, I like to say, okay, for waterworks, I create a flow chart. And in my flow chart, I go for, okay, digging, excavation, you know, I do the processes, and then which of the processes require what sort of material, what sort of workmanship, and what sort of testing required. And then, so it's all in a pictorial format to be described further in the next section later on. Okay, but let's say if you say, okay, refer to material. So materials actually your pipeline. Okay, my pipeline must be MS whatever standards. It must be what sort of thickness, what sort of cement lining, you know, and that is the material. And then the workmanship about excavation. So you must use what sort of machines, you know, how big the bucket size is, you know, and then what sort of machines, what sort of horsepower. You can feature that if you want to, if you think that is very important. And then if there's certain testing that needs to be done on the pipe, on the material itself, or on the machine itself, or on the workmanship itself, on the measurement or whatever, you must state it in the PQP. Okay? So your PQP is very all-rounded. It doesn't just talk about specification. Okay, so it has drawings, it has flow chart, it has description. It has another important element, how to measure. Very important. That is QA. Quality assurance is about how to measure, how to monitor, how to control, how frequently to control. Okay, and what rubrics do you use? That is under quality assurance. Then finally, quality control is to actually do it. You collect data from site. You see the work, then you write down, you jot down the numbers and figures and try to see if there's any problem, you try to find the root causes of the problem. Instead of reworking, at the end of it, you go and control without all this initial part, and that's it. You know, you have to knock it off, you have to cancel it out, you have to rework, you have to rectify that. It's too late already. The cost of quality will be too high. Okay, so basically that is what we're trying to cover for your quality management. You must have these three features. Create your own QMS. For your project, for your assignment, you are creating your own QMS, okay, based on these sort of elements, QP, QA, and QC. Repeat, QA will comprises of planning, how you do your PQP, your flow chart, the main flow chart. You look at how the processes of work with the material, machineries, workmanship, testing methods, and all that. So you list it all down, okay? Then after that, you also feature in your flow chart when to check. If this process B is where you check, then you will check it. And then how you check it, what rubrics you use, what form you use, what sort of quality control, what sort of monitoring tools do you use here? And then if fails, what do you do next? Do you rectify? Do you repair? So you have every stage. You catch it at every stage. So that is QA. Okay, so all your rubrics are, all your charts are, all your standards are, you know, it all is all part of QPQA. Okay, so it's featuring in your PQP. So your PQP has also got the planning. It also has the plan to control bit. You know, all your forms are, parts are, rubrics are, you know, all these things, how you monitor, how frequently do you monitor, how frequently do you test, you know, every batch of concrete comes in slump test, how many times, test cube, how many. This is all about planning to monitor and control. So that QC is about controlling, actual control. Okay, so when you control it, it fails, what do you do? See, what is your plan B? What is your plan C? So you create that for all the major work that you're looking at, okay, for your assignment. So quality management is quite a big part of your project, actually. Okay, I would say for QA, for time and cost, it's very nitty-gritty detail. So, but for quality plan, you may need to write quite a fair bit, okay, and draw quite a fair bit. So this is something that for you to draw. I will see if there's anything else I can actually. I will do PQP pre-recorded for you, and I will finish up some of these parts here in more detail, especially what we should be doing in QP, QA, and QC in maybe 1 or 2 recordings, and plus PPP in 2 recordings. So you may get about 5 or 6 recordings on quality management, and I will also do safety management in about 3 to 4 recordings. So this is some part that you will take your time to go through it. Okay. So I think quality management will probably have another 5 or 6 recordings, and then the safety management probably another 4. 3 or 4. Okay. So it will be comprising of about 10 recordings, about 100 minutes out. I would imagine 8 to 10 recordings, 80 to 100 minutes, okay, to finish up this one. So on Thursday, I won't be dwelling on this anymore. I will go back and feature onto, I will go straight into featuring on risk management. Okay, so I think that's all from me for today, and I will start to do my QR code. Any questions, please, by all means, ask as I prepare your QR for you. You understand the lecture? You enjoy the lecture on quality management? Does it help you to see better on what is quality management? Do you feel like some of the things that that you've seen in your LI, people are doing what I was saying just now on the quality checking, checking, but it's actually too late. And a lot of these are quarreling going on, a lot of arguments going on later on because of quality. Group 2 QR. Group 3 getting ready. Group 3. Okay, now we go back to group 1. Group 1, anyone who hasn't keyed in your QR? The manual one later, huh? Group 2, any more? Group 3, any more? Okay, now group 3, anyone needs manual? Group 3, anyone needs manual? Group 2, anyone who needs manual, let me open this. You can shout out your name or your numbers, okay? Anyone needs manual? Fahim Hakimi and Harith Singh Yahia. Okay, so no need, is it? Not here lah, huh? Group 1, okay. Group 1, anyone who needs manual, get ready. The speakers or whatever. Okay, list of manual. Who needs manual?
Doctor,
Yeah.
65188, Shane.
Jane. Okay,
All right. Thank you, Doctor.
no problem. Anyone else need manual? No? Okay, that's fine. Yeah, that's the story. Okay, it's done. Yeah, just watch out for the recording. I may not post it up so soon yet, you know. Could be weekends. I mean, I need to find if there's anything that I've done previously. So I'll go through it and check, you know, and then yeah, I'll probably have to prepare some of the things as well. Yeah. So it may take a few days lah, huh? So don't worry about it. Just go through whatever notes that you have first and start on your assignment. And on Thursday, I will brief you again on the manual of the company on recording lah, huh? To finish up quality management and safety management. Okay. All right. No more questions.